Good afternoon everyone, I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next lecture, that is for the data communication networks. The topic of today's lecture is CSMA CD and CSMA CA, that is the carrier sense multiple access collision detection and carrier sense multiple access collision avoidance. These are the contents of lecture are CSMA CD, CSMA C and controlled access. So, in the previous lecture we have seen multiple access protocols, different types of multiple access protocols like random access protocol is there, then there will be controlled access protocol, and there will be channelization protocol. So, these are the different types of protocols that are part of multiple access protocol. In case of random access, we have seen Aloha and CSMA, then CSMA CA and CD we will discuss today. These we will discuss today, these two topics. Then in the control access we have pooling, we have reservation and we have token passing. In case of this channelization we have FDMA, TDMA and CDMA. So, these are the channelization protocols. So, these are the multiple access protocols that are available, and today we will discuss CSMA CD, CSMA C and control access protocols, that is polling, reservation and token passing. So, this is CSMA CD. CSMA CD full form is carrier sense multiple access collision detection. Whenever more than one station wants to access a common channel and that is also in random nature, that is random access protocol. So, in that situation collision will definitely will take place, not you can say 100% all the time it will not take place, but most of the time the collision will take place, because the any of the station will not wait for a particular point of time, or will not wait or will not see or check the channel if it is free or not before transmission. Whenever I want to transmit the data, I will send the data, whether the channel is available or not, whether it is properly connected towards the receiver, whether there is some technical issue is there, or whether some other device or some other station is transmitting the data. So, that is the case for random access. So, in that context this is CSMA CD, that is a collision detection. Now, you can see over here that there are 4 different stations are there, that is A, B, C, D, 4 stations are there. These have their transmission time that has been checked from T1, T2, T3 and T4. So, these are the transmission time. Now, you can see that at point T1 first bit of A has been transmitted and it has been transmitted and received over here. Now, in this point you can see that C is collision detection and abortion is there. Collision detection means whenever any collision has taken place. So, what does it mean? Collision means there is a loss of information has taken place, it has not transmitted, it has not reached to its allocated receiver, to its allocated receiver it has not received. So, this is the first bit of A will be transmitted, then at the C this is C's collision detection and abortion will be there, then first bit of C will be transmitted and it is A's collision detection and abortion will be there. Whenever there is a collision, so in this case CSMA CD, because we are not going to change or remove that particular collision, we have to just abort the particular data which has been transmitted and it has affected with the collision. So, this is CSMA CD. Now, this is collision and abortion is CSMA CD, how it will take place. Now, you can see that this is somewhat like the previous diagram. At point T1, this is the part of A's frame which has been transmitted over here. This is time T2 and T3, this is the transmission time. Then this is part of the C's frame is there, that is known as the collision which has occurred over here. Then this is T4, this is the transmission time which has been seen over here. A will detect the collision and it will going to abort the data. C will detect the collision and it will going to abort the data again. So, this is known as the collision and abortion in CSMA CD, which is been shown over here. Now, next is the flow diagram of the CSMA CD, that how this whole process will work. This is start, means station has a frame to send the data, it will initiated the sending, it has initiated the frame to be transmitted. Then this is the 0th attempt, means it will be the initial attempt that has been done. Apply one of the persistent method. We have seen all the persistent methods, 3 persistent methods are there: L persistent, P persistent and non persistent. In case of L persistent method, the sender will continuously watch the sense the channel whether it is free or not, and whenever it is free it will going to transmit the data. In case of non persistent method, it will check and it will wait for a particular point of time, then it will check again, then wait for a particular time of point of time, it will wait, and then when it sees that the channel is free, then it will transmit the data. That is the case for non persistent method. In case of P persistent method, there is some probability and operations will be performed when the frame will be free for the channel will be free for the transmission purpose. Now, next is eligible for transmission. Transmission is done or the collision has detected. If the transmission has done or collision has detected, if it is yes, then it will check that whether the collision has detected or not. If it is not detected, then success will be there, and if it is detected, then it will going to send a jamming signal. Before that, we will see if it is transmitted and received, means collision has not detected, because the name is CSMA CD, collision detection is there. If it is not detected, then it will go back again, and again the transmission procedure will start again. This is for the next attempt that has to be made, because we have sent a jamming signal. Then maximum number of attempts in this case also which is possible, that is 15. Normally, we have put to 15, that in 15 attempts it will going to transmit the data perfectly and it will going to receive the data perfectly before collision detection has taken place. Then choose a random number between 0 to 2 to the power k minus 1. So, we have to check the number. Then wait for the TB time. What is TB? TB is nothing, it is the back of time, that is R multiplied by TP or R multiplied by TFR. What is TP? TP is nothing, it is the maximum propagation time. So, for this time duration it has to wait and it has to go back again to the next attempt that has to be, if it has to be made. So, this is the flow diagram of the CSMA CD. Now, next is the energy level duration during transmission, idleness and the collision. So, how this energy level distribution is there whenever there are 3 situations are there. 3 situations means whether it is the situation for collision, means after the transmission the collision has taken place. So, in that case we have to check the energy level, and next is the idleness, whenever the channel is idle, whenever it is not used for any kind of transmission purpose. So, that is the case for idleness, and third case is the frame transmission, means the actual transmission of the frame is going on. So, that is the case for energy level diagram is being shown over here. Now, you can see that during this transmission, we are not talking about ideal and this situation collision. In this frame transmission duration, the energy of this is quite low as compared to the duration when the collision has taken place. Whenever the collision has taken place, definitely the energy will going to increase, it is higher as compared to the frame transmission, because in case of frame transmission the data will be transmitted at a very what you will say a very constant rate, it will not going to fluctuate, but in whenever the collision has taken place between the 2 stations, between the 3 stations or between the 4 stations, then definitely the energy will going to increase. So, that is the case for collision. Now, next is the ideal situation whenever there is no transmission has taken place or reception has taken place between the transmitter and receiver. In that case, the energy will be 0. E will be is equals to 0 in that case in the ideal situation. So, that is the energy level during transmission, idleness or the collision, because any one of the 3 options or the procedures will be performed, other than that there is no work will be performed whenever we are set up a network. Now, next that is all about the CSMA CD collision carrier sense multiple access collision detection. Next we will see carrier sense multiple access collision avoidance. Whenever we see there are 2 cases are there. First, in first case when the detection is there and we have to then avoid or we have to remove the collision, that is not possible, we have to just abort that particular packet. But in this situation carrier sense multiple access collision avoidance, we have to do some work so that the collision will not take place, because in that situation definitely there will be loss of information has taken place and we have to make attempts means maximum 15 attempts we are having and we have to transmit it again and again and again. So, to avoid that we have to initially we have to work on that, so that the collision has not taken place. Now, in CSMA CA the IFS can also be used to define the priority of the station or a frame. If the station finds the channel busy, it does not restart the timer of the contention window. It stops the timer and restarts it when the channel becomes idle. So, this is very simple. Whenever transmitter or any of the station wants to transmit the data, it will continuously watch that particular channel. Then it will start that timer that it has to stop or wait for that particular time interval until for the next time it will going to check that whether the particular channel is free or not. Okay. Then if one time if it sees that channel is busy, then it will stop the timer and then restart again, and the channel will become, it will restart again when the channel becomes ideal. So, in this situation there is no collision will take place, it is definitely it will be avoided. So, this is the flow chart of the CSMA CA case, that is the carrier sense multiple access collision avoidance. We have to start the work, then it has to start with a 0th attempt. This is the number of attempts that has been done, this is the first attempt or the 0th attempt. Then this is the ideal channel, this is the ideal channel where it has to see that whether the channel is ideal or not. If it is not, then it has to make a second attempt. If it is ideal, then it has to wait for the IFS time, this is the timer. If it is see that if the channel is still ideal, then it will choose a random number. If it is not ideal, then it has to go again back again for the next attempt to be made. So, this is the case for the CSMA CA. Now, next is choose a random number r between 0 and 2 to the power k minus 1. Now, what is k? The maximum value of k will be 15. In all the cases we have taken maximum value k max will be is equivalent to 15. Okay. Now, this is the contention window. Now, k will not be 15, we have to take the value 2 to the power k minus 1. Now, this k is not all the time 15, whatever attempt I am making, like I am making a second attempt, then 2 to the power 2 minus 1. So, that is the case, that is the random number that we have to choose. So, this is the case for choosing a random number r between 0 to 2 to the power k minus 1. Now, we have to wait for such number of slots, that is the r slots, then send the frame, then wait for the time out, and then acknowledgement will be received. Now, this acknowledgement, if it is received correctly, then we have to send a yes, then success, the reception of the data will take place. If it is not, then we have to send a k is equals to k plus 1, means next attempt we have to made. Now, k will always, if it is greater than 15, then you have to abort. If it is not, then we have to go back again and check whether the channel is ideal or not. So, this is how this collision avoidance will be performed in this random access protocol CSMA CA. Now, next is timing in CSMA CA. Timing in CSMA CA, how it will work? You can see that this is the channel window, okay, and this is busy. In this duration, it is busy and it will continuously sensing that particular channel. Then, if it is at this point of time, it shows that it is ideal, then it will wait for that IFS time. This is the IFS time, it is the timer that has been set, then it will wait. Then again, this is the binary exponential and it is the size of the contention window in which you have to transmit the data. Then after that contention window, you have to send this particular frame, and this is the time out. After you have sent the data, after you have sent a frame, then you have to wait for the next acknowledgement to be received, or you have to wait that whether it has received correctly or not, and then the timer out will be there. Means it will going to make busy that particular timer for the time being when the data will not be received. So, this is the case for CSMA CA. Now, next we will move to controlled access. What is controlled access protocol? Controlled access protocol is the next type of multiple access protocol, which consists of reservation, polling and token passing. Three different types of protocols are there. In the controlled access protocol, the stations will consult one another to find which station has the right to send, which means it will check that whether the second station has the data, whether the third station has the data, whichever station has the data, it will going to transmit the particular information. Then a station cannot send unless it has been authorized by other stations. Until and unless it has not been authorized by the other stations, it will not going to send the data. Means it is a collective situation, like 4 stations are there. Each station wants to transmit the data, then it will going to check that which station has the data. It is done in a very controlled manner. So, we will discuss these 3 methods. First one is the reservation access method. What is reservation access method? Reservation means there are, this is known as the reservation frame. We have reserved already 5 different frames with the bit that is known by 0. Okay, so, this is known as the reservation frame, which has 5 bits, 5 bits each is 0, 0, 0 and 0. Then there is a data at the station 1 is there, then data at the station 4, 3 and 1, this is all again is there, that is the reservation access method. Now, these are the different frames which are been written over here, and you can see that this means 1 means the data from the first station has to be sent. So, this is how the reservation access method will work. It will going to check that whether the first station has to send the data. Then you can see in this diagram, this is the first, this is third and fourth. So, 3 different frames are there, which will going to transmit the data, which is denoted by bit 1, 1 and 1 is there, and this is denoted by 0, which is not having the data, or which is not, these are reserved basically, which is not showing that whether which station has to transmit the data. So, this is how this 1, 2, 3, 4, 5, these are the different frames which are been written over here. Now, in this diagram you can clearly see that if the frame color is denoted by 0, and secondly if it is shown by this white color. So, you can clearly see it is reserved. There is no fixed pattern is there, that whether first frame will transmit the data, second will transmit the data, or third will transmit the data. But whenever we are highlighting and we have shown this by one is been there, means that particular station will going to transmit the data. So, that is known as the reservation access method. Now, next is the select and poll functions in polling access method. Second type of controlled access protocol is the polling method. What is polling method? Now, first thing you have to see that what is SEL. SEL means select, ACK means acknowledgement, okay. Then NAK, this NAK means negative acknowledgement, we have seen negative acknowledgement, we have seen this. If it is written as ACK, then it definitely means it is positive acknowledgement, it does not mean it is negative acknowledgement. Whenever it is negative acknowledgement, then it will be written as NAK. Now, how this will work? As you can see in this first diagram, this is the primary which will going to initiate the transmission, which wants to transmit the data, and there are two stations are there, two computers are there, that is A and B. It will going to select any one of the secondary, these two are secondary one, it will going to select any of the secondary computer. So, it has selected this one B1. So, it has selected by sending a frame, that is that is shown by SEL, it has selected that particular frame. Then it has sent an acknowledgement that yes, it has selected, you can see over here, yes, it has selected, means a connection has been set up between the frame between this primary and the secondary computer B. Then the data will be set up, will be sent, and then again the acknowledgement will be received at the primary end. So, this is the polling function is been there. Now, next type of transmission is there, that this is the primary, these are two are secondary. It will going to poll, means poll meaning means it is a kind of, we are checking, we are asking that whether you are free for transmission or reception or not. Then it will going to check that whether second one, that whether you are free for transmission or not. So, it is kind of you are asking that please connect with me, I want to transmit the data. If it has sent a negative acknowledgement, then the connection will not set up. If it is a positive acknowledgement, then it will going to send the data. This is the case which has been seen over here. It has polled to this, it has sent a polling frame to this station A. Then it has sent a negative acknowledgement that yes, I am not free for the reception or free for receiving any bit or whatever the case, means it has sent a negative acknowledgement. Then it has sent a poll function, a poll frame to this second station, that is denoted by station B. Then it has been, it will going to receive the data, and then an acknowledgement will be sent that yes, I have received that particular data. So, whenever we are transmitting data, we have to receive an acknowledgement in reverse direction. That particular acknowledgement will going to decide that whether it is a negative acknowledgement or whether it is a positive acknowledgement. If it is a positive acknowledgement, then it means that yes, that particular frame or the packet has been received correctly. There is no point of retransmission, there is no case for retransmission, and also if it is negative acknowledgement, then another transmission will have to be performed. Now, next type of protocol of the controlled access protocol is the token passing protocol. So, this is very interesting kind of protocol that we have seen over here. There are 4 different types of configurations that are available, logical ring and physical topology and token passing access method are there. Like first one is the physical ring, second one is the dual ring, third one is the bus ring, and fourth one is the star ring. So, from the ring you can consider that it is a closed loop first thing. Okay, so this is a closed loop, means 4 stations are connected over here. This is a physical ring, means 4 stations are connected in a ring form, they will going to transmit or receive the data in the ring form. Secondly, in case of this dual ring, there is a dual path has been connected between this first station, second, third and fourth station, like this is shown by this black wire and this is shown by this pink wire. It will going to transmit and it will going to receive that particular data. So, that is a dual ring, means if in one direction it is shown by this one and in the reverse direction it will also going to receive that particular data. Now, next is third type is the bus ring. You can see that this is the backbone. Okay, so, this is the backbone which will going to transmit the data. So, these computers or stations are connected to this backbone through this tap lines, and this will form a bus and this will going to transmit the data. Now, next one is the star ring. So, in case of star topology, if you remember that there is a hub which is an intermediate node, whenever we want to transmit the data, then it will be transmitted using this hub. So, in all the 4 cases, what is the main purpose? Whichever station is having the token, it has an it can transmit the data. If I have the token, then I can transmit the data. If I do not have the token, then I cannot transmit the data. So, this is all about the controlled access protocol. So, these are the references that you can go through for this controlled access protocol. Thank you.